Okay, we are back with a few more released items using a little bit of algebra and a whole bunch of Desmos. So let's go ahead and look at number 6. It's one that's not too terrible to try by hand, so we'll go ahead and look at that. Remember, if you're dividing here, that's to keep, change, flip. So I can replace that fraction by just saying I'm going to multiply by and flip that upside down. So add to the next. Got too close to the edge of my screen there, and let's see if I can undo the damage. Yeah, there we are. The x minus 2 to the negative 2 needs to go on top. I don't have any room to write that to the negative 2, sorry. And that's a x minus 3 to the negative 1. I'll write to the negative 2 up there maybe. And now what I need to do is I need to, that's gone. So now I am ready to multiply and simplify that out. The only problem is I've got a whole bunch of things with negative exponents. So remember, negative exponents are unhappy. They don't like where they are. So basically anything with a negative exponent needs to switch sides of the fraction. So this goes up to the top. This thing here goes down to the bottom. And then anything to the positive 1, I don't have to list that exponent if I don't want to. This negative 1 can go on top, and once again, once it's a positive 1, it doesn't have to have that exponent. And then the negative 2 makes it go down to the bottom to become a positive 2. So now I have made a lot of progress so far. The next thing I'm going to need to see is that I have the same thing top and bottom here. So this will cancel out. So any answer that has a x minus 2 in it doesn't seem to be right. And you're like, but what about this quadratic? Well, this is something that will factor. So remember, I'm looking for things that multiply to 6 and add to negative 5. You could, of course, put that in Desmos to factor. But that will be a negative 2 and a negative 3 is what that will simplify to. And now since you have an x minus 3 on top and x minus 3 on the bottom, they cancel out, and you have 1 over x minus 2. Now I mentioned the word Desmos to factor just to make sure we're all still clear on that. I could have gotten that to factor as well by, sorry, I need to clear out some of this other stuff that's here, by just typing in a x squared minus 5x plus 6. And basically these zeros are the roots I get when I do that. Get my graph back home, are 2 and 3. And remember, if I have roots of x equals 2 and x equals 3, when I make factors, the sign switches, put them in those parentheses, so that's why it's an x minus 2 and an x minus 3. So I could have factored with Desmos. Now, quite frankly, you could have done Desmos on this whole thing. You could have played matchy-matchy on the graph. It would take a little bit of patience getting this typed in correctly, so it probably wouldn't be my go-to strategy. But just to show you, you could do it. I could do the first thing. So I could have had a x squared minus 5x plus 6 to the negative 1 over x minus 2 to the negative 2. And then that whole thing gets divided by, and don't be afraid about the fact they put another fraction there. Just go ahead and put in your x minus 3 to the negative 1, and then in your second denominator, if I can get down there, is an x minus 2 to the negative 2. So that's going to give me that graph. Doesn't tell me a lot, but if you check your answer choice that we think it is, 1 over x minus 2, you notice that the graphs match exactly. If I toggle off the green, you can see the blue. It's a perfect match, even if you were to zoom in. So that is a way you could have checked it using Desmos, or you could have checked all the answer choices, and that would have been the only one that worked. But for sake of time, we'll move on. We have a company in this one making spaghetti, and we're looking for a machine filling the box with about 32 ounces of spaghetti. So here's one thing to consider. 32 ounces is basically my goal. So, and after the boxes are filled, the machine weighs it, and it discards if it's off by more than this. So, ooh, and I have managed to scroll again. Hold on just a second. Sorry about that. The 2.5 ounce, how much it is off by, that is your margin of error, how much it can be off by. So remember, what we're doing is we're comparing the weight of the box to the goal. And when I compare, the best way to compare things is to subtract. If you were, 5.5 feet tall and your brother was 6 foot tall, you would say, okay, the difference between my height and my brother's height is half a foot, because you would subtract your heights to find the difference. So to find the difference, we compare. So that means I'd have absolute value of x minus 32. And then you want to be close to your goal weight. You don't want to be making boxes of spaghetti that are way too heavy or way too small, so that's why you have the less than or equal to get close to the 0.05, and then the absolute value says it's okay to be under or over as long as you're close. So this is how you set that up. You could check this with Desmos, and you're like, can you check everything with Desmos? And the answer is almost. If you did this with Desmos, I think the testing calculator will do this. Remember, you can do the vertical bar, or you can go to the functions, miscellaneous. Actually, sorry, don't even have to go functions miscellaneous. There's your absolute value right there. I apologize for that. But then you could try the x minus 32 is less than or equal to the 0.025. And how this would work is we get a little window of acceptable weights, and you can kind of use that to figure out if it's right. What this graph has done is said it's got to be close to 32 ounces, and it can be off by a little bit. So if you look at that, you can be off by, right about 0.25 either way, which is what the problem's asking for, which lets me know that's the right equation. If you would have tried one of the other problems, like, for example, some students get really tempted with answer choice A. You could see from that would be like, no, that can't be right, because it's saying I can have boxes of spaghetti that weigh anywhere between 32 and negative a whole bunch ounces. So that's way too big of a range. You'd never stay in business making spaghetti that way. So that's how you can check your answer using Desmos, but I usually do those without Desmos if I can. Okay, the graph of the equation is shown below, and which equation represents the graph. Hopefully you can narrow it down without going to Desmos, but notice this graph has been moved down too. It has not been shifted left or right from the origin. It looks like it just went straight down. So moving a graph down should be a -2 on the outside. And let's see, it looks like I like answer choice A. Let's say for some reason you liked answer choice C. You can always go to Desmos and try the absolute value of x minus 2, and go back to a normal home zoom. Be like, no, that didn't go down 2. Maybe Mr. Hass was right after all. -2 gives you that, and that's how you get those answers. Let's go ahead and do another one. On number 9, you've got, these are rate problems. We did a few of those this year. But basically, the idea is you need to find the rate for each person. So Martha can do 1 room in 2 hours. That's Martha's rate. Jamie can do 1 room in 6 hours. So that's Martha's rate is 1/2 of a room an hour. Jamie's rate is 1/6 of a room an hour. And they're going to work together. So if they're working together, we want to add their rates and see how long it will take them to do 1 room. So her rate times the time, Jamie's rate times the time, and that's going to equal 1 whole room. At this point, I could, find a common denominator and solve that way. It shouldn't be too bad. The common denominator would be 6, so that would be 3/6x plus 1/6x equals 1. That means I would have 4/6x is equal to 1, and then multiply both sides by 6/4. We get that to cancel out. And that means my answer is 6/4, which reduces to 3/2 or 1.5. Now, when I do these, I always check and make sure my answer is reasonable. If Martha gets the room done in 2 hours and Jamie gets it done in 6 hours, clearly if they work together, if Jamie's doing any good whatsoever, it should make it get done a little bit faster than the faster person, Martha, would on their own. So that seems like a very reasonable answer. I mentioned solving with Desmos. If you wanted to do that, you could just have, the 1/2 x plus 1/6 x And you notice how I had an equal one. The testing version of Desmos will not handle that. It gives you this little exclamation point that says you can't do that. The quick way to fix it is to get everything on the left side, so just subtract 1. And then now you're looking for the 0 or the x-intercept, which is 1.5. That's how you would solve it with Desmos. One more. I've got two functions, and it says, what is the y value when they're equal? Well, this is definitely a Desmos problem in my opinion, because if I'm looking for an equal y value, I'm looking for the places where the graphs touch or intersect. So I've got f of x is equal to, do not have to type in that f of x, but sometimes you like to, is 2x to the third. I'm sorry, I'm forgetting my own trick to minimize the calculator instead of going back and forth. And then plus 2x minus 3. And then this one is a g of x equals negative 0.5. If you're using a Chromebook, the absolute value bar is right under the backspace key. So you can do shift and the key right under the backspace will give you that bar, or you can pull it up on your menu. You can get the absolute value however you want. Now what we're looking for is a place where the y value is equal. So you get gray dots in Desmos. Notice that one's an x-intercept, not what we want. That one's a y-intercept, not what we want. That one is the place where the y value is equal. And it says, what is the x value where the y value is equal? So your answer would be, I'm sorry, it says, what is the y value when it's equal? So my answer would be negative 1.75. So it didn't ask for the x, it asked for the y value when they were equal to each other. So the place where two equations are equal is where they intersect. I hope this helps you on these problems, and we'll do some more next time.